Hello students, I am Dr. Vivek Vijay from SKIT Jaipur. It is lecture 3 on recurrence relation. In lecture 2, we have find CF and PS for given question. Now we use PS, ARP in given equation. It implies capital A 4 power R plus 5 capital A 4 power R minus 1 plus 6 capital A 4 power R minus 2 equal to 42 4 power R. It implies taking 4 power R minus 2 as common, then this will 16A, 20A, 6A is equal to 42 4 power R. It implies this is 42A is equal to 42 4 square. 42A is equal to, that means A is equal to 4 square is 16. So PS is equal to ARP is equal to 16 4 power R. Hence, complete solution is AR is equal to CF plus PS. C1 minus 2 raised to R, C2 minus 3 raised to R plus 16 4 raised to R. If in the question initial conditions are given, then using these conditions and we find the C1 and C2. Otherwise, this is our answer. Now, other question. It can be written in the form of N, not in R. Now its solution. For solution, taking FR equal to 0, AN is equal to alpha raised to N, AN minus 1 is equal to alpha raised to N minus 1, and AN minus 2 is equal to alpha power N minus 2. Then alpha raised to N minus 5 alpha raised to N minus 1 plus 6 alpha raised to N minus 2. And it implies alpha square minus 5 alpha plus 6 is equal to 0. After solve this equation, we get alpha is equal to 2, alpha is equal to 3. So CF is equal to C1 2 raised to R, C2 3 raised to R. As given, Fn is equal to Fn equal to, so this is not R, this is N. Fn is equal to 3n square minus 2n plus 1. It is a second degree polynomial in N. So ARP is equal to it is also a second degree polynomial, A n square bn plus c. Using it in given equation, then we get an square plus bn plus c in place of small an minus 5 a n minus 1 square plus b n minus 1 plus c. This is in place of 5 small a n minus 1 plus 6 a n minus 2 square b n minus 2 plus c, and is equal to 3n square minus 2n plus 1. If we solve this, then we get two an square plus coefficient of n equal minus 14a plus 2b, and the term without n 19a minus 7b plus 2c, and this is equal to 3n square minus 2n plus 1. On comparison both side, we have system of equation capital A comma capital B comma capital C. Solving these equations, we get the values of A is 3 by 2, value of B is 19 by 2, and value of C is 39. So ARP is equal to 3 by 2 n square plus 19 by 2 n plus 39. Finally, our complete solution is AR is equal to CF plus PS. It means AR is equal to C1 2 raised to R plus C2 3 raised to R plus 3 by 2 n square 19 by 2 n plus 39. This is our answer. Another question is that is an plus 2 minus 4 an plus 1 plus 4 an is equal to 3 2 raised to n. As given, fn is equal to 3 2 raised to n. Taking fn is equal to 0, an plus 2 is equal to alpha power n plus 2, an plus 1 is equal to alpha power n plus 1, an is equal to alpha power n. So we have characteristic equation as 1, and the root of this characteristic equation is 2 comma 2. These are real, and repetition value 2 occur 2 times. So CF is equal to, this is the case 2 of CF calculation. 2 occurs 2 times. So CF is equal to 2 raised to R A1 plus A2R. Now we use C1 in place of A1 and C2 in place of A2. These C1, C2 are arbitrary constant. And since in the question there is not R, there is N, subscript is N. So we are using, this is N and this is N. अगर पिछले एग्जाम्पल में कंप्लीट सॉल्यूशन के वक्त यहाँ हमने पावर R लगाई है CF के लिए, तो वहाँ पावर N कर लेनी है, बिकॉज लास्ट क्वेश्चन वाज आल्सो फॉर N. After opening this bracket, in this question, after opening this bracket, we can write C1 2 raised to n plus C2 n 2 raised to n. Since Fn is equal to 3 2 raised to n equal to k alpha power n form, where k is equal to 3 and alpha power n is equal to 2 power n occurs 2 times in CF. So this is case 5/3 of particular solution. So we can write particular solution is equal to ARP is equal to capital A n square alpha power n equal to capital A n square 2 raised to n. In this question R is not available, so we write n suffix. Using A and P in the given equation, we get a n plus 2 square 2 raised to n plus 2 in place of 8n plus 2 minus 4a n plus 1 square 2 raised to n plus 1 in place of small a n plus 1 and plus 4a n square 2 raised to n in place of a n equal to 3 2 raised to n. Dividing every term with 2 raised to n, then we get an plus 2 square minus 4an plus 1 square into 2 plus 4an square is equal to 3. Taking 4a as common, then we have this equation. Now here n square plus n square and minus 2n square cut, plus 4n minus 4n cut, and we get 2 is equal to 3. It implies a is equal to 3 by 8 and a and p is equal to 3 by 8 n square 2 raised to n. So complete solution, an is equal to cf plus ps. It implies an is equal to 2 raised to n c1 plus c2n plus 3 by 8 n square 2 raised to n. The remaining part of recurrence relation in lecture 4.